Hey folks, so this is lesson 35. It's a very short one, so there is a second part to this lesson which is about a slightly different topic. But we're going to look at order of magnitudes, and it's fairly simple because you've probably done this already if you've done scientific notation. So we're going to learn how to use these and to give examples of large and small scale objects. So first of all, can you put these into the correct order? Pause the video and have a wee look, and also can you write these in standard form? So the correct order from smallest to largest would be minus 18, this one here, then minus 10, then minus 6, then minus 5, then 4, then 8, 14 and 23. Hopefully you can write these in standard form. If you don't, then you really are going to be struggling with higher physics, folks. Now, standard form is very important because it's useful for us to write numbers that are very, very big or very, very small in a compact way. And you can see here, we've got three numbers there that we've written in standard form. And you know from our special relativity that we can be dealing with very, very large numbers, especially if we're dealing with things like the speed of light and the light year. In terms of particle physics, we deal with the opposite end, which is the very, very small numbers. So again, it's really useful for us to write things in standard form, as you'll see later on. So what do we mean by the order of magnitude? Well, for example, say we had the sun has a mass of something times 10 to the 30 kilograms. Well, the times 30, the index 30, would be called the order of magnitude. So it has an order of magnitude of 30. So quick question for you. True or false, times 10 to the 30 kilogram is half of times 10 to the 60 kilograms. So pause the video and have a wee think. Correct answer is false. And the reason for that is because remember, this is a scientific notation. So times 10 to the 60 means there are 60 zeros after a number, whereas here there is only 30 zeros. So these are totally different numbers. This, in fact, is a lot bigger. In fact, the correct way we would say it is that it is an order of magnitude 30 times bigger. And I'll explain how we get that in the next slide. So, why do we talk about order of magnitude? Well, each time we increase an order of magnitude, we're multiplying by 10. And that makes sense because if you think about it, each time we increase this number here by 1, we're really adding an extra 0 to our number, aren't we? So that's the same as multiplying by 10. And you can see the importance of knowing your order of magnitude in this wee cartoon here. So how do we use this order of magnitudes? Well, here's an example I've got, which is 3 scientific numbers. And you can see it's 1 times 10 to the 2, 1 times 10 to the 4, and 5.6 times 10 to the 6. Now, because these numbers are raised to a power, 2, 4, and 6, we can kind of ignore the bit at the front because they're not going to make that much of a difference in terms of the order of magnitude. So the first thing I would say is that the order of magnitude of this is 2, the order of magnitude of this number is 4, and the order of magnitude of this number is 6, even though it's got the 5.6 up front. Now, in terms of the size of these things, I would say that this to this one, the second number is 2 orders of magnitude bigger than the first number because it has 2 extra zeros than this one here. If I was talking about the first number and the last number, I would say this number here is 4 orders of magnitude bigger than this number here. So that's how you get an idea very quickly of the size of things compared to each other. Now, how big is big? So I'm going to try something new. I'm going to try and put this link onto the video so you can click on it a bit later on and you can see this really cool video that shows you the scale of things from the very, very small on the Planck scale, which we'll talk about later on, to the very, very big. We're talking about stellar objects, and it's a really nice video. I definitely recommend you watch it. So here are some key lengths for you to try and remember. You don't need to remember the exact number, but it's remembering the order of magnitudes. So the diameter of an electron is roughly an order of magnitude of minus 18. Okay, remember the number up the top there. Very tiny electron, as you can imagine. The wavelength of red light is on the order of minus 7 meters, although normally we write it as 700, so that way we can call it a nanometer, which is a bit easier to say than 7 times 10 to the minus 7. And length of a school lab is roughly about 10 meters, so the order of magnitude in this case is 0. Distance to the moon is about an order of magnitude of 8, so you can see compared to the electron, there is a massive difference between the order of magnitudes of these two things.